Hello, this is Bronya. Welcome to my webinar about JavaScript. Today we're going to talk about control structures. By the way, I know that we have two types we haven't talked about yet. Didn't forget. So control structures. What are control structures? Control structures change the flow of your program. It's the basic way how to change the flow of your program. There are different ways. Control structures are the basic way. They exist in pretty much every language. Not every, literally, but almost every higher language. As we've seen, the program runs from start to top, from start to end, from top to bottom, from start to top. Nice. 5 true, false, true. 5 true, false, true. We already explained that. Some concatenation of the string. But sometimes we need to branch. We need to change the flow. For example, someone insert value and I want to check out, well, if the value is something, let's say someone inserts a login name and a password, and I want to check out, and what I want to do is if the login is correct, let the user pass. If the login is incorrect, let's do something else. Well, it doesn't work in just top to bottom flow. We need to separate. So we'll start with this control structure, which is if. If has basically this syntax. If else. This is the basic syntax. This creates a block of instructions. So whatever is in this block of instruction between those two brackets happens if this value, which evaluates to Boolean, it has to be some sort of Boolean value. Well, if it's true, then this happens. If it's not true, this happens. So value equals 5. I'm using the triple equality. Check it out. It's 5. It's not 5. There can be as many instructions as you want. Both those instructions happened. So that's if. Technically, if there's only one instruction, you don't need to create the block. What you can do is basically this. It's 5. It's not 5. If I add something to this, let's say it's not 5, this would happen, because this else belongs to nothing. there has to be an expression, something to do. Block creates an expression. So this is one expression that contains other expressions. But actually this happens. This is still correct. So this evaluates, this is false, so this is not going to happen, and only this happens. This if belongs to whatever comes next, the expression that comes next. And this is the continuation of the program. That's equal to it. This, by the way, I'm using indentation to separate different levels of blocks. So I can do something like how does this work actually? Well, nothing shows up, even though this is correct. Well, this comes first. So if value equals 5, then this block applies. If it's not, nothing happens. Nothing in this block actually happens. So this doesn't get evaluated. So it's really truly about the block that's there. And I'm using the indentation to show where I am. This would be really, really hard to read, especially if you had like a big block, a lot of things one in the other. So JavaScript doesn't care about white space. I can use the white space to separate levels. I would go okay, this applies. I'll do this. This applies. So this doesn't apply. I don't do this. Again, you pretty much won't be able to read this. It doesn't matter where this is, where the curly braces are. I can write it this way. It's still valid code. The white spaces do not matter. This is valid code. This is still valid code. This is still valid code. It doesn't matter. It still follows the syntax. A condition, if condition, then block or expression, else another block or expression. It still works. There are different types how to actually write it in a code. This is one type. Some people prefer curly braces on a separate line. I prefer this. Stick to one. It's the best thing you can do. Just stick to one. And as I said, this has to evaluate to true. So we can use the thing we were talking about when we talk about type coercion, the Boolean type coercion. You can check out value. This evaluates to Boolean, which means it takes the 5, converts the 5 to Boolean, which is true. Okay, there is something. Now there's nothing at all. There is something. There's nothing at all. So you can use this shorthand of the coercion. I said that there's a way of coercion that can be useful, which is this Boolean coercion that can actually work. But as I've said, technically, maybe you accept the 0 as a value. For example, you want user to add a value, to put a value. And 0 can be actually a valid value for something. For example, imagine a calculator. If user does something like this, user press 2, so you're going like, okay, I have 2. User presses plus, so you'll go, okay, I'm gonna do substitution. And if user adds nothing, you can be, okay, I'm still expecting a value. User adds 0, that's valid, that's 2. That's an expression that can be evaluated. So this wouldn't necessarily work here. You would actually have to go, since we're expecting strings, for example, if it's not empty string, gonna do some evaluation. Is it number? Is it some operator? You have to know what you're asking for. So even though this implicit conversion, the coercion, can be sometimes useful, you still have to know why are you using it. And as I've said, when you're evaluating, always go for this, the triple evaluation, not the double evaluation, unless you explicitly require type coercion. But as I've said, it can be tricky. You can chain that chaining. Let's say we want to test for numbers 4 and 5. In case of those numbers, we want to do something. In case of other numbers, we just don't want to do anything. How can we do it? Okay, we can do something like this. If it's 4, okay, it's 4. Okay, if it's 5. So if it's 4, we're going to write, okay, it's 4, else. If it's 5, we're going to write, okay, it's 5. And if it's not 4 or 5, we're going to write incorrect. So incorrect, still incorrect. Well, it's 4, it's 5. Well, that's incorrect. We can write it differently. We can write it better way. There are actually two ways how to write this. One is using, again, the if-else statement. Another way is using a different control structures called switch. How can we write it differently? I think this should work. Let's do it this way. That looks strange, but it's still working. It's incorrect. Well, that's 5, 4, 3. It's incorrect. Why? Why does it work? Well, as I've said, it requires an expression, something that can be evaluated. This is one expression that can be evaluated. This is sort of like it's one line. It's sort of like this. If there is some condition, there is a block here, and that's else and something. Since it's one expression that can be evaluated, it doesn't matter if you write it this way or you write it, you put it in a block, or you type it like this. It's especially useful when you start to seriously chain things, because now let's say we want to do something for 4, 5, 6, 7. Well, if we do it the old way, we would have to go like this. Seven. 4, 5, now it's 6, now it's 7, and incorrect. So this is incorrect. 4, 5, 6, 7, 8 should be incorrect. This could go forever. This is slightly simple to read, it still parses. And again, this is one expression. Now this is one expression up to sort of, okay, let's put it this way. This is one expression of this if statement, if else statement. So this is one. So we can write it and not put it into block. So this becomes one expression, and then this becomes one expression. I usually suggest stick to the point if block else block, even though it's one liner. While this is correct, someone, even you, can look at it and say, okay, I just don't want to do this, I want to do this as well. As I've said, this is not going to work. In this case, it will actually produce an error, but if you would go this way, it wouldn't produce an error. But it looks like, okay, if it's true, let's do this and this. But this is gonna get evaluated all the time. The same applies if I would go like, for example, this is still valid. But this gets evaluated all the time because what belongs to else is this single line. So it's seriously best to put it in curly brackets. This is pretty much one exception that's perfectly okay, perfectly valid, and perfectly readable. And it avoids this issue because incorrect. Okay, this should happen when it's 7. This should happen when it's 6. Because the actual what should happen is in the block. The else is pretty much the only thing that isn't. So that's the first control structure. It creates a branch in your code. There are other ways how to do similar things. The first way how to do it is actually using an operator. It's a very special operator. It's a ternal. By ternal I mean it accepts 3 parameters. It looks like this. Let me find it. It's here. Conditional operator. It's actually one operator, although there are 2 symbols, the question mark and the colon, but it's actually one operator. And what it does, it evaluates the first value, turns it into Boolean, and if it's true, it does what's behind the question mark. If it's false, it does what's here. So this is actually a very fast way how to do let me rewrite it a little bit. Now it's equal. Not this. I want this. This is wrong. This is okay. This is the same. This is actually the same. There's no difference whatsoever. If this is true, do this. What's between the question mark and colon. If this is false, do what's in the column. What's behind the column. If this is true, do this, else do this. I can rewrite it, the original. So will work as well. Why? I definitely cannot do okay. This is valid syntax. It doesn't do anything. There is nothing to do here. That's okay. Wrong. I cannot do this, of course. This is an error. Because, well, this isn't an expression. This doesn't do anything. This just branches. It's a control structure. It doesn't return anything. It's not the value. This is not a value. So you cannot write this. You have to actually write it this way. Evaluate and then do something. But you can write this. Yeah. But you can write this because this is an operator. It returns value as any other operator. When you add things together, if you multiply things together, if you compare things together, it returns a value. It returns a number, it returns a boolean, it returns string. So this actually returns a value. Is it 6? Then okay. If it's not 6, return wrong. So this returns a value. The value is either okay or wrong, depending on what's here. It's an operator. You can chain this as well. For example, like this. See, 5. But you shouldn't do this. It's really hard. It's really hard to read. It's really hard to read. Where is it, by the way? Lost it somewhere. Let me find it. I'm blind. Here it is, conditional actually. It's evaluated right to left, the associativity. So it goes, okay, there's an operator, so I'm gonna evaluate it right to left, which means first I evaluate this, and then I evaluate. So here I get 4. Is it equals to 5? No. So I get wrong. Is it equal to 6? Either okay or wrong. It's evaluated from right to left, but it's really hard to read. So you should not chain them. Or you can do something like this just to make it better to read. Just to make it easier to read. For example. But I still wouldn't suggest to chain this operator together. But it's a nice way how to, again, branch branch the program, this way using control structure, this way using operator. Let's check out switch. Let me put it this way. Last thing. This isn't mandatory, of course. It still works. Now it does nothing, because there's nothing to do in the program. Still does nothing. Okay, now it's 6. It's okay. Still does nothing. You should always know why you don't have else here. That's weird. Why are you working with only this value? Why there isn't a branch for another value? You should always know why. It's a good practice to simply comment it. Just make a little comment why there is no else. Just to know, because the next time you can get back to this piece of code, to this specific piece of code in 3 months, half a year, and you're going to be watching at the code and figuring out, okay, so there can be some sort of value, and I don't care what should I do for the other possibilities. Why? And you're going to be figuring out why. Just comment it. Or just, you can do this. So make an empty else and put a comment in it, just to let yourself or anyone else who's going to be working with your code know why. Why have you done what you've done? So that's if. Similar control structure is switch. Like this. I think it's like this. 5. 6. Default. Okay. Come on. Okay. Okay, this looks a little bit, there isn't a block, there is a block. I'm gonna explain it. What switch does? Switch pretty much works like if. So let's check out the value, what it is. While if works on true or false, a switch actually compares any value, but you put only the value here, and the comparison works with the case. So in case value is 4, there is a colon to separate again the expression. This is still 4, it's just an expression. It returns a value, it's 4. Let's do anything until the next break. If it's 5, do anything until the next break. If it's 6, do anything until the next break. In all other cases, which is the default, do this. There is no break here. Okay, it actually works with the break as well. I just forgot. It happens. This is a sort of strange indentation, but it's up to you how you do the indentation in this case. In case of switch, apparently breaks work here, but block works as well. Well, it's still a block, which means this should work perfectly fine. Still works. This is probably the best syntax how to do it. So why is there a break? First of all, what happens if there is no break? Will it fail? No. It works until the next break. So this evaluates to true. Okay, I do this, I don't care about this one. I stop with the next break. This is false, I don't do this, I don't do this. Okay, 5. I stop with the next break. You can write several cases one after the other. Because it always stops at the next break. So even if you put this here, okay, this evaluates, this is correct, so let's stop on the next break. If I put 5 here, well, this is correct, let's stop with the next break. Speaking about switches, let's talk about what people usually call logical operators. They're actually not in JavaScript. Although they're called logical AND, logical OR, they work differently, slightly differently than in other languages. So what they do, they can chain conditions. So let's say we're gonna check out if value is 5 and another is 6. So you would do, whether using if or whether using switch, both do pretty much the same, as you can see. Value equals 5 if another equals 6, five or 6, 5 not or, 5 and 6. Please go away. Okay, 5 and 6. If I change this, nothing. If I change this, nothing. Yeah, if value is 5, do this. If value is 6, do this. But, well, that's a lot of typing. And especially when you want to do something, if it's not 5 and 6, so you would have to go not 5 and 6, and you would have to put it here as well, because both can fail. And this is 5 and 6. this doesn't evaluate, it jumps here. This is still correct. This doesn't evaluate. So if you want to do the same thing if it's not 5 and 6, you would have a problem. For example, okay, this is a validation of login name and password. You do the same thing twice. Let's say you would want to validate 3 things at once. Well, you would have to do another if here. I'm actually 40. Well, this doesn't look good at all. Can we chain it? Can we somehow make it 1? Well, we can chain conditions with logical operators. So I can rewrite this as if login is Bauglir and age is 40 and password is webinar. Hello. Else it works. If I change any of this, it doesn't work. So this is like a logical AND. It's not exactly logical AND, it behaves like logical AND. How does logical AND behave? So what's true and true? True and true is true. True and false is false. False and true is also false. False and false is false. So the only time something that's connected via logical true or logical AND is true is when both are true. It goes from left to right. Not bitwise, this one. So it evaluates. Okay, so how it works? This is true because it's in parentheses. Okay, there's a logical AND. So this is, let's evaluate this. This is true. So this, all of this is true. So we have true, and let's evaluate this. This is true. True and true is true. If any of this is false, So okay, this is true, this is false, true and false is false, false and true is false. You can or cannot. Where is logical and where is... Oh, nice. Okay, this seems like it's working. Because equality has a higher precedence than logical AND, which means okay, this gets evaluated first, there's an AND password, but there's also this, which means I have to evaluate this first, then I can evaluate those two. But again, reading this, remembering, okay, the precedence, does it work, does it not work, it's better to actually type it like this. So that's logical AND, that's also logical OR. Let's say I want to give access to if login is now clear or login je pro ně. Where is unexpected token? Okay, here's I'm missing this, of course. Hello. Hello. Nah, you cannot pass here. So that's logical OR. How does OR behave? OR behave as an OR behave. True or false is true. Okay, let's start with true or true is true. True or false is also true. False or true is true. False or false is false. So at least one. AND works like both of them, or works like at least one. And again, you can chain it. So that's logical OR. They don't work actually like that. The fact that they work like in math, in logic, it's nice coincidence, or it's a desired effect of something bigger. What would you expect this does? Well, it returns actually string. If this was logical, purely logical, it would convert. This would return true, because this is true, course to boolean, this is true, course to boolean. Okay, that's true. It returns bronya. It returns actually string, not a boolean value. So how do they work actually? A logical AND works like this. Evaluate the first from left to right. Evaluate the first. If the first evaluates to false, return the second as it is. Or works if the first evaluates to true, return the first. This is how it works. And it works like this as well. True or false. If the first evaluates to true, return the first. Okay, true, return true, return true. This evaluates the false, so let's go to the second one. So that's true. It's false, so let's go to the second one, which is false. So it works with logical values, but it doesn't have to return logical value. In this case it does, because this returns logical value, this returns true or false. Something was added. Nothing. Okay, this evaluates to Bauglier, so let's evaluate the second one and return the second one. It's password. Well, that's empty string, and this string converts to Boolean because we're using if is false, so this doesn't happen. So how it works is it goes where it's necessary to go to evaluate. So in this case, come on, it evaluates login, so it has to evaluate password as well. It goes here and returns this. In this case, this is already false. So and false and anything is false. So it doesn't do this. This no longer evaluates. Okay, this part no longer evaluates. It doesn't run. It's very rare in the language that you have an expression and it doesn't run at all. It doesn't have to. The computer doesn't have to run it. Let me show you. I'm gonna do something that we haven't talked about yet, but let me check it out. We used some functions already. We're using the console log. We talked about the functions like number, doing conversions. We're going to talk about functions more. Let me write my own function. We're going to talk more about functions, but this effectively means, okay, there's some block and I can call it from different place. And the return says, okay, this block is returning value. This is like big operator. Imagine it like a big operator. Actually, operators are like small functions. So I'm gonna run this. When the program goes here, it's gonna run this. So it console logs something and returns a boolean. And then I'm checking for correct password. I'm gonna log it here. Let's start with this. This time it's correct. So it's gonna run this function. This function returns true. It's not enough. True is not enough to evaluate end. Because if this is false, this would be false. If this is true, this would be true. So it has to evaluate this as well. Okay, so it actually goes through here, it goes through here, and then it evaluates. It still evaluates both because this is true, but that's not enough to evaluate everything. So it has to go through here. This is incorrect. This doesn't happen. This never ran because this is false. And JavaScript already knows if it's false, I don't have to do this. That's completely unimportant for me to do. If I put or here, okay, it's either Bowglir or it's webinar. Okay, that's correct. And it went through both because this is false. False is not enough to evaluate or. False or true is still true. So it has to evaluate this. This case, this is true. But because there's or here, it's going to be true. Regardless of what it is. So it doesn't have to evaluate this value. This returns empty string. This returns the first value because it's already false. Okay, we call it falsy. There are values that are called falsy and values that are called truthy. Falsy values, when you convert them to boolean, are false. Truthy values, when you convert them to booleans, are true. As I've said, it returns this value. It doesn't return this value, it returns this. If this is false, it returns the first value. If it's true, return the second value. This is true, I don't have to evaluate the rest, so return the first value. This is false, I have to evaluate the rest, return the second value. People usually learn this later on in JavaScript, but it does behave a little bit differently than in other languages. Where was I? Where was the think this one, wait a second, I playing some music, but I have to play not copyrighted music. Where is it? Here? Tak. Okay. So basically it works like logical operators that you know from math or from other languages, but it behaves a little bit differently. But it still works with logic, as it should. It returns the first, because it's already false. It doesn't even go. This actually returns the second one. Because this is true, let's return the second one. This returns the first one. Because the first one's already true, I don't even care about the second one. Okay, let's return the second one. Because the first one is false, I have to go for the second one. And those are logical operators, and as I've said, they're very useful in if statement. I'm gonna show you something else with the if and switch. Let's say I want to compare two numbers. B is bigger. Sounds correct. A is bigger. Sounds correct. A equals B. Okay, that's correct. Can you do this with switch? Well, switch compares. Takes this value and compares it to this value. But I cannot take a value like, there are different values here. So how can we do it? In this case, we were just evaluating one value. This looks like evaluating two values. So how can we write it? What's going to be here in its value? There may be some evaluation here. Well, we're comparing true. We rewrite value equals 4 to this. Value equals 4. How do we do this? Can we? Does it make sense? Of course we can. Because we're comparing values, so we're comparing true to this value. Is it true? No. Is it true? Yes. So it ends up in this case. So you can actually rewrite it. It looks strange, but you can actually rewrite it because it's comparing a value. Like in this case, it's comparing a value. If this value is 4, do this. If this value is 5, do this. If it's 6, do this. So if this value, which is true, is this, or this, or this. So you can rewrite it. Here, this is the same. Because all of them are exhaustive, there is no other way, and mutually exclusive. Which means this is actually the only way what can happen. Now this can happen. There is no like other default, other possibility for this to end up. It's either bigger, lower, or equal. So when you have a bigger if statement with a lot of possibilities, it may be useful to rewrite it in switch. I don't usually use switch. It's not because switch is worse in something. It does exactly the same thing as an if statement, but it's a matter of just I'm used to if. That's it. That's all there is to it. So that was a conditional structure, and next time we're gonna work on loops. Thanks for watching. Broniais out.